The Project Manager allows me to open, create, review the settings for, or delete projects. If I want to open a project, I just highlight the project in the left selection panel. I can review the settings of that project in the central area. And if I've selected the right one, pick Open Project. Zoom to Extents shows me my project. I can return to the Project Manager by picking on the plumb bob and Projects. If I want to delete an old project, I can pick on what's called the hamburger button and I'll see the delete option. If you pick outside of that option, then it cancels the action. If I want to make a new project, pick on the New Project button in the top right corner, tap inside the red field and give the project a name. It's important to note that the project name cannot have any spaces in it, but numbers and letters are perfectly acceptable. When I pick on Done, the name is recorded. I can select other settings, including coordinate system and units, and when I'm ready, create project. It automatically opens in the survey screen. And that's all I've got to show you in the Project Manager. Thanks for your interest. In the Map View panel, I can adjust settings that control the display of the map view in FieldGenius. I've opened this panel from the bottom right corner. I can turn these toggles on or off to display point names, figures, or the scale bar. Below that, I can control what type of information is streamed over my wireless connection. I can view road maps, I can view satellite imagery, I can view topography, or if you want to save on data, just ask for none. You can also adjust the opacity of these screens, but be careful that you don't have opacity off because it may still use your wireless data in this case. Down the bottom we have the Auto Center button. If I pick on it once, then it automatically moves my current position as shown by the GPS to the center of the screen. I can pan away from it later on and it won't update. But if I want to make it so that it constantly follows my current position, I can turn that toggle back on. And now as I move around on the screen, you'll see that FieldGenius automatically pans to continue to show me in my current position. I can also control my visibility using standard Android gestures. Let me turn that feature off. I can use a single finger to pan in any direction, or I can use a pair of fingers and I can use the pinch to zoom method, so I can zoom inwards or outwards, and the zoom will always be towards the center between my two fingers. Thanks for learning about visibility in FieldGenius. The Theme button in the bottom center on the screen allows me to select options for different color schemes in display. And here I'm just switching between the white on black and the black on white themes. Depending on your visibility conditions, one of those will be preferable. The External References panel, over on the left side, I can highlight it by selecting this icon. This allows me to layer information from different projects or different sources. In this example, I'll show you how I can layer on some additional information that come from this job site. Currently, we're looking at the GIS database definitions of some lot layers. So if I check on this FGA sample 2, what we're able to do is view the results of some traverse work. I can also check on FGA sample 3, and we'll find that there was some RTK work that was done on site, and that also gets displayed on the screen. And I can turn these off. All you have to do is just slide the panel over slightly to refresh the view. So you'll find that these are layered in there for reference, but they will still act as though they're a part of a different project, just there for reference. Thanks for learning about the External References feature. The Observations toolbar appears when you have the Instrument toolbar open, and you can tap on it to cycle through different types of information. So here we're looking at the GPS metadata about the position that we're receiving from the receiver right now, and you can see that it's got green check marks, which means it's meeting all the requirements of the current tolerance mode. I can also cycle through, and I can see speed and path across the ground. Here I can see my lat long, and there I can see my coordinates, and those values should be updating as we move around, and that's a little confirmation that you've got a live connection to your instrument. Thanks for learning about the Observation toolbar with me. When I'm staking a point, if I open up the Observations toolbar, I'll see as I tap through it that it gives me additional information. So currently it's giving me the delta east, delta north, and delta elevation to get from my current location to my staking destination. And as I move closer, I'll see that that updates itself automatically. And now that I'm close enough, I can see that it even highlights in green when we're within the staking requirements. I can also tap through this same screen, and I can see a display that gives me the direction and the distance to my staking point. I can see my current latitude, longitude, my current map projection coordinates, and more information about my GPS sensor quality and GPS sensor speed and path across the ground. If I want to see this in full screen, notice how over on the right I've got two other options. So I can pick on the full screen button, and there I've got staking directions in full screen. Or here's a half screen option that gives you a different way of viewing things. Thanks for your interest. The Points Data panel allows me to manage points in my project. I've opened up the Points Data panel on the left-hand side of my screen, and currently it's allowing me to review all the points on my project. If I want to highlight a particular point, I can actually pick it off the screen, and when I select the point, then it jumps to it in the points list, and it allows me to either edit it or stake it. If I just touch away from the points panel, then it clears that setting. Currently, I'm reviewing all the points in the project, but if I want to, I can add a filter. And so here I'll filter by a code, and I'll tell it to show me only points with the code of road. And so once I set up the filter, I hit apply, and now we see we're only looking at 7 of the points in the project. Another neat feature with that is when you've got a filter set up, if you zoom to extents, then it will only show you the filtered points instead of the whole project. If I want to go back in, I can clear my filter, and now I'm back to looking at all the points. We can also get into more detail by picking down in the bottom left corner. You can see we've got the full screen icon. So that'll open up, and now I've got a much more detailed listing on each of the points. So I've got the point classification, I've got whether or not it's part of a figure, I've got the point ID, the code, the XYZ coordinates, and if I pick on the extended options button here, I have the option of either editing or deleting that point record. And that's all I've got to tell you about the points panel. Thank you. You can manage the code list for your project just by picking on the panel on the left and selecting this icon so that we can look at a list of all of our current codes. Watch what happens down in the topo toolbar in the bottom left corner. When I select a different code to set as current, then it automatically switches over so that that is the code that will be used when we store a point. Thanks for learning about the code list feature.
Hello, this is Ken with MicroSurvey. I'd like to show you a new feature we've added to FieldGenius for Android in our version 1.6 release. We've now added the capability to define custom coordinate systems in FieldGenius for Android. So you do that when you set up a new project. I'm just going to tap the new project button here. You can put in a project name, set up your units, and when you get to your coordinate system, select the more options, little hamburger on the right, and load your coordinate system options. So we still provide all the predefined coordinate systems you can select, but if you need to define a custom coordinate system now, go ahead and tap the custom coordinate system option buttons and then select Define New. I've already done that in this case, so what I'm going to do is just open up the UAE1 custom coordinate system I've set up and edit it so you can see what needs to be put into the custom coordinate system. You provide the name that will show up in your list, your ellipsoid parameters, the radius, equatorial radius, polar radius, that'll then calculate the inverse flattening. You can select your datum type, and you can select from a number of different options for the datum type. In this case, I'm using a 7-parameter datum, and then go ahead and input your custom coordinate values here for the delta, x, y, and z, your scale factor, and then your rotation for the x, y, and z as well. Once you've got those entered, you can then come down and select your projection type. In this case, we're using the transverse Mercator projection. And once you've selected that, you can then go ahead and enter the information you need for the central meridian, latitude of origin, your scale, and any false easting or northing you need for your custom coordinate system. When done, go ahead and hit the Save button. This will now show up on the list, drop down under Custom Coordinate System, and to select one, you just need to open the drop down and tap the Custom Coordinate System to select it, and then go back and complete the other options for your new project and create the project. So I've already done that, and I'm just going to open up the UA demo project. One of the nice things about FieldGenius for Android is we do take whatever coordinate system you're in and do the transformations to display it on the map so that you can see all our background maps. And in this case, what you see is that our location now is in this case, United Arab Emirate, and you get the northing and easting and height in the custom coordinate system. One thing to note is if you need to edit your custom coordinate system, you need to actually open a different project than the one you're working in so that the coordinate system's not in use. So in this case, I'm just going to open up a project, a different project, go back to custom coordinate systems. And now when I create a new system, that gets me to where I can access the coordinate systems. So I'll load all my coordinate systems. The UAE1 is now not in use, so it's available, and I can select the edit option. If it is in use, you will get a warning screen, and that's the process you have to do to go back and edit the custom coordinate system. Thanks.
Let's start a new project and import a text file. Create my new project. Make sure that you set your units and your coordinate system, and I'll create it. Now I don't need to connect to my instrument yet. I'm just going to go to Import. So I'll browse to where I have a text file stored. In this case, I happen to have it in my Images folder. There, I've selected it. I want to specify that it's comma delimited. I want to specify what the coordinate order is, and I'll specify what the units are. And by the way, FieldGenius will convert your units if necessary, if they're in a different unit, and it'll just check against the project settings before it does the import. Pick on Import. Say OK to that. And if we go back into the survey map view, we can see our points are imported. Let's take a look at exporting and sharing. I've got a number of observations here, and I'd like to export a text file. I'll go back to the main menu. I'll select Export. I can select from coordinate file or raw file. In this case, it'll be a coordinate file. I can designate a name here. Just ensure that your name doesn't have any spaces. You can overwrite the suggested one, or you can make up a new one. You can decide whether or not you want to include a header, and you can pick the format that you want. You can also decide if you want space or comma delimiters. When you pick on Export, it's going to export all the points in the project, and it gives you a path where the points file has been stored. You can connect with a cable and browse to that location, but with Android it's a lot handier to use the share function, so I'm going to pick on share because this takes advantage of a feature in the operating system that allows me to pick from a variety of ways to share. So I can either email it by picking the Gmail icon, or I can store it to my Google Drive. In this case, I'm going to store it in my Google Drive. As soon as I've done that, it gets copied over, and all I have to do is log in to my drive in Chrome, and I'll be able to copy it to my desktop. Thanks for your interest in this topic.
Hi, this is Ken with MicroSurvey. I'd like to show you a really cool and useful feature we've added to FieldGenius for Android for our version 1.6 release. We've now added the ability to completely back up an existing project on an Android data collector. So now on the projects list on the left here, you see you have an option button. When you select that, you have backup as an option for that project. So it creates a backup file with the file name of the project name, the date and the time, and an archive of the project. So we've created that project, and you can select Done, and it's saved in the archive folder in your FieldGenius folder on the device here. Or you can select the Share option, and again select another place to store it. You can store it on My Drive, up in the cloud. You can email it to someone, and so forth. So what will happen is that file will be saved, and you can transfer it from device to device. It will bring everything you need to open and continue work on this project on a different device. So if you're in the field and somebody else is doing the work the next day and you want to transfer the project, you don't have to actually physically transfer the device. You can just send him the file. He can open it on his version of FieldGenius for Android and continue the work. To restore a new or a backed up file, when you open your FieldGenius for Android on the new project, there's now a options button at the top here on the left, and you can select Restore Project. And now we can browse the device to figure out where we want to select the project that we want to restore. As I'd mentioned, it's stored in our archive folder in our FieldGenius folders. So in this case, I just created the UAE demo project, and if I hit the restore button, it'll go ahead and restore that project to the device. If the project already exists, as it does in this case, it gives you the date and time of the incoming project, the date and time of the one that's existing, and you can either overwrite or cancel. So this makes it very easy to store and back up projects for security, as well as send a project either to the office for review or to a colleague to look at, where they can open the complete project and look at it on their device. So again, a very cool feature, and I think it'll be very useful for moving data around between Android devices or to the office. Hi, this is Ken with MicroSurvey. I'd like to show you a new feature we've added to FieldGenius for Android in our version 1.6 release. We've added the ability to connect to WMS map servers so that you can get images that can be displayed as a background on the map view screens. First, you need to set up your WMS source. To do that, from the main menu, go to Settings, and then Map Tiles. This is where you can select the type of map you want to be displayed as a background. And we've added now the WMS option at the bottom here, which needs to be configured. So if you select the configure wheel, you'll get a list of the map surfaces you've already set up, and you can edit those or delete them. I'm going to add a new service, and this one I'm going to give it a name of Topo. And then you need to provide the URL address of the WMS map service. The best way to do this is look it up in a browser, get the address, and copy the address link, and then really just paste it in, like I've done here. If it's a private map server, you can put in your username and password so that you can log onto the server when you select that service. So you can select one service to use as a background map. So I just created Topo, that one's selected. Now if I go to my survey map screen and I go to the map configure icon in the bottom right, I can bring up my mapping pop-up and I can turn on different options. But now one of the options for map view is the WMS option. So we can select that, and now you can see it's using the map from the WMS map server. This is a free Government of Canada map that I'm using here, just a Topo map. And again, whether it's maps or images from the map server, you can connect, get them downloaded, and display them as a background map in your project. One thing is, again, the speed of download is dependent on the connection and the map server. Thanks. Hi everyone. I want to give a quick demonstration of a new feature in FieldGenius for Android version 1.5 that we're getting ready to release. This is the ability to import a DXF file from CAD as a background layer. To do that, you can go to Import, select your file type, in this case DXF, and then I can browse for the file I want. So I can either look on the device here if I've moved it here, or I actually have this file up in Google Drive. So I'm going to go to my drive, into my imports folder I've set up, and select the file I want to import. And I can import it in meters. That's the default for the project. If the file's in US Survey feet, I will do a conversion from feet to meters when it imports. But in this case, I'll leave it as meters. And I'm going to attach this file as a XREF, an external reference. So I've loaded the file. Now I can go straight into my map view and see the DXF file. So if I go to my external references data panel, I can see that I've got it turned on. To deselect it, I just unclick and select it as well. So I've attached the layer. So I can attach different layers to the map I'm working with. I can also set that DXF as selectable or not selectable. In this case, I want to work around, I just want to see what's behind it. I tap on the map, I'm selecting nothing. If I decide that I want to actually take one of these points and use it in my project, I'll turn the selectable tab on. I'll select the point I want, and I'll add it to the project. I'm going to keep the same number. I could change it if I want, and I can save it. You can see now that it's a little darker and a little more prominent. So we've added that point to our points database. The other thing I could do is add a line. So in this case, I'm going to select the line. I'm going to say OK. And I've added that line to the lines database. So now you can see that I've got both the line and points that I've added to the points database. So when I selected that line, I selected the line, but also the vertices at the end of each point. So that's a quick demo on our new feature of how to add an external reference DXF file to FieldGenius for Android. Thanks.
Let's look at measuring a single point using GPS. Before I start to measure a point, you'll notice that the point number that's going to be assigned is already shown in the topo toolbar, and I'm going to update my current description code so that it uses road. If I want to add a figure, I can in this button, but I'm going to show that in a different video. So once we've got our code set, we can open up the instrument toolbar, and if we can see that it's passing the requirements of our tolerance mode, then we just pick on the measure button. If we've told it to average a number of observations, it will cycle through those observations, and then you've got the option to store the position. So there it's applying the point ID and the code, and it's showing us the calculated coordinates for that point. When I pick on Save, then the point has been stored. Thank you for learning about storing a single point with me.
Hello, this is Ken with MicroSurvey. Today I'd like to show you the auto record feature that we've added into FieldGenius for Android version 1.7. The auto record feature allows you to collect many point readings rapidly without having to trigger each observation individually. To set up the auto record mode, tap your measure button on your instrument toolbar and select the auto record option. You can now configure your auto recording for the points you're going to measure. You can choose between distance or time mode. I'm going to leave it at distance and set your interval. In this case, 3 seconds or 3 meters. You could set 3 seconds if you wanted. It's a good idea to review your antenna height, as this antenna height will be applied to all measurements taken in auto record. If you need to change it, hit the three-dot menu on the right. You can also set the point number that you want for the first point, and then each point after that will be incremented by 1. And again, as we're doing auto record, you're not seeing the measure or the new point review screens. You're just storing the points as you go along for speed. So you're not getting to see the point names and approve them one at a time. You can also then set your code, whether it's points or lines. In this case, I've selected bottom of curve. And the next line in the sequence is line 11. I can set the tolerance settings and apply them to the auto record measurements. So if I'm set up for RTK fixed and I don't want to record any measurements that don't meet that tolerance, I can check this box on. In this case, I'm just going to leave it off and record all the measurements as I go through. Once I hit start, we'll go back to the main map view, and you can see that on the bottom we have the stop and the play button on the bottom toolbar on the left. Once I start this, it'll gray out the individual measure option for recording. So I'm going to start walking and hit the record button, and you'll see that there's point 800 as I move along and 801. We also have a new toolbar on the map that you can see that the points are being stored as you move along. If for some reason a point isn't stored, it will be shown as not stored in that bar. You can also still monitor the position and the status of the GNSS receiver on the observation toolbar. When you're done measuring your points on this line, you can hit the stop feature. And as you can see, we stopped, but I'm still moving along. So if I go to the next line that I want to measure, I can start up again. And you'll notice that on the line code here, BOC 11 ended and a new line, BOC 12, is automatically starting. So again, if I want to go to auto record mode, just hit auto record. I know that I want to start at point 810 again, so I can just hit start. And if I start walking again and hit the record or play button here, we'll start with point 810 and again continue on and store points as we move 3 meters down from the last point. So this is a quick demonstration of how auto record works in FieldGenius for Android. Thanks.
Manual point entry is accessed from the finger button that you see down in the bottom right corner of your screen. When I select that button, it allows me to approximate the value of the coordinates that I might want to store, and this is an optional step. If I want to pan to an approximate location, I can do so, and then pick on plus in order to finalize storing the point. Here I can enter my desired point ID. I can select a code from the code list. I can overwrite the actual coordinate values. Once I'm finished, I can save my point, and it gets stored in the project database. I can pick done, and I can go back to regular surveying. If I wish to cancel doing a storage point, I'll pick on that same operation, I'll pick on plus, and in this case I don't want to save, so I just pick the back left arrow button and I pick on done. And now no point is stored. Thanks for your interest. When I'm in surveying mode, the topo toolbar allows me to view the point number that I'm about to store, and it also allows me to set a code for the point that I'm about to store. I can pick on that code and I can switch it from my project code list. Thanks for your interest. The full screen points list is a feature that allows you to see detailed information about points and also to edit points. So the default points view is the data panel on the left-hand side, but if you want to get into the full screen points list, look down in the bottom left corner where we can pick the full screen icon. So that allows us to see more detail, and if we want to delete or edit points, I can pick on the further options and that will appear. Alternately, I can reach the full screen points list by going back to the main menu, going into project data, asking for information about points. There you go. That's how we get to the full screen points list. Thank you. Here we'll talk about how you can draw line work as you're storing points. If you look at the Topo toolbar, you can see that we're ready to store a point 25. We're going to assign the code road to that point, but in the figures area it says none. So I'm going to pick on where it says none, and this will open up our figures list. And in this case, I want to create a new figure, and I'm going to give it the code of BB. Pick on Create BB11. And if I scroll down, I can highlight BB11 and I can set it to active. Now we're going to start adding to figure BB11. Let me store my first point. And we've begun our line work. And then as I move my way to the southeast, we'll see that the line work is being drawn as we go. I'll store another point. And I'll move on and we'll do a third point. Store that point, and you can see that the figure is being stored as we work. Now when I'm finished drawing that figure, I can just tap on where it says BB11 to edit it, or if I just want to end it, pick on the X that's right next to it. Now that it says none, I can continue to store points and no more figures will be drawn. Or I can start a new figure. Thanks for your interest. Let's take a look at storing a point and doing line work at the same time. So I'd actually like to extend this figure that I've highlighted in red. So I've picked on it, and we'll see as I scroll down on the list that this is figure number BB10, and if I set it to active, now it'll automatically draw the line work as we store the points. So all I have to do is check that my tolerances meet the requirements by using the observations toolbar and pick on the measure button, and if it's accepted, I can store the position. After I save that point, we can see that the line work has been drawn already. If I just close this screen, we'll see that this figure is still active as we work, and if I want to turn that off, note down in the bottom Topo toolbar, I can just pick on the X and it will now be inactive. Thanks for listening.
Hi, this is Ken with MicroSurvey. I want to show you our annotation feature we've added to FieldGenius for Android in version 1.7. When you take an observation now, you can store notes in the annotation field on the Details tab. So trigger your observation, and in the New Point screen, you can scroll down to the bottom and find the annotation field. Here you can tap in the annotation field, it'll bring up your keyboard, and you can type in the note that you want to associate with the point. We do support all input types that are configured on your Android device, so if you have set up handwriting recognition or voice to text, you can use that. In this case, I've set up voice to text, and I'm just going to talk into the microphone on the Android device, and with a good internet connection, it'll convert that to text. You can quickly save it and move on to your next observation. The notes saved in the annotation field are associated with the point and stored in the project folder. So if you archive the project and send it to the office, all your notes will move with the project, and it's easy for the office to look at them and then include the notes in reports and deliverables to the customer. This is a quick overview of the annotation feature added to FieldGenius version 1.7. Thanks for watching. Hi, this is Ken with MicroSurvey. I want to show you some cool new features we've added to FieldGenius for Android in our version 1.6 release. Based on feedback from customers, we've redesigned the user interface to allow better workflow in the field when working with points and lines from the map view and the data panel. So now if you tap on the map view in an area where you want to select something to work with, such as points or lines, it'll bring up the pointer line in the area you tapped. I'm going to work with point 17. And what it does now is it brings out a pop-up right to the front that gives you options for that line. It's edit, zoom, creating new points, doing an inverse. You can delete the point now directly from the map screen or go straight to staking. And you can even inverse a point to a line. If you don't want the screen, or you just want to highlight that point, again, tap right off there. It's quick and easy to close. The same thing from the data panel on the three-dot menu. Just tap that, and now we bring up, again, the edit screen of what you might want to do with that point and allow you to navigate, straight away to one of the functions. For in this case, I'm going to do a quick inverse to point 822. I get that, and I can close it and go back to work. Same for the lines. If I take a look at, in this case, line LL5, tap that and select it. Once it's selected, it'll bring up the menu of things I might want to do with that line. Same thing, edit, zoom, create a new line. In this case, we can close the line if we want and make it a closed figure, get information on the line, go delete it or go straight to staking, and so on. So in this case, I'm going to just select staking and go straight there. So as you can see, we don't have to go back through the main menu, go to the staking menu, all that. We go straight in, and we have the line selected. We see where our rover is, and we can go straight into staking that line. So that shows you some of the cool new features we've added in just navigating through the application to make it easier to use out in the field. Thanks. Hi, this is Ken with MicroSurvey. Just want to give you a quick video here on how easy it is to get an area of a closed figure in FieldGenius for Android version 1.7. We've added the functionality to be able to get an area with just a couple taps, select the line, it brings up the quick action pop-up, and then you can select line information. Now you can see at the bottom of the page here we've got a closed line. It gives you the perimeter, the total slope length, and the area. And since I'm using metric, I get it both in meters square and hectares. So you do need a closed line. So for example, if I select line LL2 here, it's not closed. If I go to information, you'll see that I just have the line information. However, if I want to close that, again, it's just a couple quick pop-ups here. I'm going to select LL2. I'm going to close that. So now that I've closed it, I can select it again and go to information, and you'll see that I now have the area of that figure. So just a couple taps to get area now in FieldGenius for Android version 1.7. Thanks. Hi, this is Ken with MicroSurvey. Today I'd like to show you a new feature that we've added to FieldGenius for Android in our version 1.7 release. We've added the ability to take a photo and associate it with a point that you're measuring. So if you take an observation, and you'll get the measurement screen, and once the measurement is done, you'll get your new point screen. Now there's two tabs, the Details tab and the Media tab. If you select the Media tab, you have two options. You can take a photo with the Android device using its camera, or browse the folder system to select a photo. In this case, I have selected the camera and positioned it and taking the picture. Once the picture's done, it will store it and associate it with the point number, so 10_1 in this case. The other option is if you've already taken a photo, you can browse your file system and select the photo that you want associated with this point. Just select it, and again, it's added. Hit the Save button, and you move on to taking the next measurement. Once you have stored the points, if you look at the map view, you'll see the blue circle now that indicates the number of photos that are associated with each point. You can use the Map Properties button on the bottom toolbar and toggle off the Media option, which will remove the blue circles beside the point number. So once you've got the points, you can also open up the Data panel. We've added a new Media tab to the Data panel. So when you select that, you'll get the thumbnails of the points associated with the project. The thumbnails will show either number 1, 2, 3, 4 if they're general project photos, or point number _1, 2, 3 if they're associated with a specific point. It's also easy to work with these points. You can remove a link from a specific point if you don't want it. You can delete the photo if you don't want it in the project, or zoom to the point right away if you want to find the point that's associated with the photo you see in the thumbnail. One of the cool things is that all the photos are in the project folder. So when you go to archive the project, all the photos that you've taken in the project are archived and all the associations. And so it's easy to send the photos to the office for people to work with them and include them in reports. So this is a quick demo of how easy it is to take photos with FieldGenius for Android version 1.7. Thanks for watching. Welcome. This is the MicroSurvey FieldGenius for Android how-to video on using the inverse COGO function. To access the COGO functions from the survey main map view, select the COGO icon, which is the calculator, and then select the COGO function you want to use, in this case, inverse. This will open up the side data panel for the workflow for inverse. And now you can select your points. You can select points either by tapping on the map, by selecting the point from the points list, or by typing in the point number in the field. That will then display the inverse from point 6 to point 7, the direction and the distance. You'll also notice that in the workflow we have now replaced the start point with point 7. So if you want to get an inverse to the next point, it is fairly quick and simple to select that point and get the inverse now from 7 to 13. When you're done with the inverse function, select Close to return to the main map view. Thank you. Welcome. This is the MicroSurvey FieldGenius for Android how-to video on using the traverse COGO function. From the survey main map menu, go to the COGO icon, which is the calculator. Select that, and then the function you want to use, in this case traverse, and select that. This will open the COGO data panel, which is a workflow that is synchronized with the map view to allow you to conduct COGO calculations and save points. In this case, we will pick a starting point. You can either click on the map to select the point, you can select it from the list, or type it in to the field. So we'll start from point 6. Now we can put in the direction we want to go and the distance. You can see the traverse point, the location, and you can see it on the map as well as the inputs in the data panel, and click plus to add this point to the points database. As you can see, we now use point 19 as the starting point for the next part of the traverse, but what I'm going to do is change the azimuth here and put in a new direction. And you can see as I'm putting in the direction and I've got a distance, it's showing the point. If I remove the distance, it will just show the direction off to the edge of the map. So in this case, we'll put a distance of 15 meters and select Done. Again, I can add this traverse point to the map and continue on with the traverse. If at any point I want to not save the traverse, when I review it, I can just use the back button. And when I'm done using the traverse function, I can select Close. Thank you. Welcome. This is the MicroSurvey FieldGenius for Android how-to video on using the COGO line intersection function. From the survey map view screen, select the COGO icon, which is the calculator, and then select line intersection. This will open up the data panel that has the workflow for calculating line intersections, and this is synchronized with the map view. So you can select a starting point either by selecting the point on the map, by selecting it from the list, or typing it into the field. Next, select the azimuth that you want to run the first line intersection from. In this case, I'm going to put in an azimuth, and as you see, as I put the azimuth in, you can see the construction line going from point 6 outward. Next, you can select the next point. In this case, I'm going to select point 7 and just type it in. And then select the azimuth, and I'm just going to run this one straight north. And as you can see, we get an intersection solution here. So when I select Done, we will have a solution where the two lines intersect. I can now add that point to the points database. So with the workflow and the construction lines, it's very simple to see the line intersection where that point will be added. So this completes how to construct a point on the intersection of two lines in FieldGenius for Android. Thank you. Welcome. This is a MicroSurvey FieldGenius for Android how-to video on utilizing the line offset option when we're doing line intersection. In a previous video, I've showed how to calculate a line intersection using the COGO functionality within FieldGenius. What I'm going to do now is turn on the line offset option to calculate a new intersection point. From point 6, I'm going to add an offset of 5 meters. As you can see, this shows plus 5 meters. So along the line, it is 5 meters to the right of the line. And from point 7, I'm going to add a intersection of minus 10 meters. And you can see how the construction lines are synchronized and dynamic. And this allows me, when I select Done, to calculate a new intersection point for these lines utilizing the line offset option. Thank you. Welcome. This is MicroSurvey FieldGenius for Android how-to video on how to use the station offset function in the COGO tools. From the survey main map view, you can select the COGO tools icon, which is the calculator, and then select the station offset option. This will open up the data panel, which has the workflow for setting up a station offset. You can take your start point, one of 3 methods. You can either click it on the map to fill in the field, you can select it from the pull-out points list, or you could have just typed it into the field. Also now I'm going to select the end point. So on this line I'm going to select point 7. And so I'm going from point 6 to point 7, and along this line I'm going to take my station 5 meters along the line, and I'm going to take an offset of 10 meters from the line. And as you can see, we are dynamically calculating and showing the synchronization between the entries in the data panel and where the point will be on the map. Once we have a solution, the solution box opens. It gives the coordinates of the point and the plus button to add the point to the points database. You can review the point and then save it to the points database. As you can see, we have now utilized the station offset COGO functionality to create a new point 19. When you're finished with your station offsets, you can select Close to return to the map view. Thank you.
Hi, this is Ken with MicroSurvey. Today I'd like to show you a new feature we've added to FieldGenius for Android in our version 1.7 release. We've added the COGO function Rotate, Translate, and Scale. So if you hit the COGO function on the bottom toolbar and select Rotate, Translate, Scale, you can then select the manually entered option. This is the only option we support at this time. This will bring up the data panel that allows you to select the points you want to work with. So first off, I'm going to reverse the order here and go descending order, and then I'm going to hit the Select All button because I want to work with all the points that I've imported here into the project. And I do have one control point that I'm going to deselect. You see I unchecked it and it's not selected anymore, and hit the Next button. This will allow me then to review the points that I'm going to work with. So again, you can select a subset of points within the project to move. So first I'm going to scale these points. Got a couple of options, user entered or calculated. I'm going to select user entered, enter the base point, number 1. I want to scale from and the scale factor. And you'll see that when I enter the scale factor right away on the map view in real time, you can see where the points are going to be based on this move. So once I've scaled the points, I can then apply rotation to them, simple angle or direction. Again, I'm going to rotate these around 0.1 and add a rotation angle. And as soon as I apply the angle, you can see that the points are rotated around 1. So it's easy to see what you're doing as you use the RTS function. Finally, I'm going to translate the points. I'm going to take the origin point and the destination point. And I'm going to move these to the control point in my project and then see how they line up on the map. So now that I've done this, I can check against the background map and see that they're lining up where I expect them to. I'll hit the next button now, and this will show me the movement parameters that I've input on this move. I can then store the points, and they'll be written to the database, and I can work with them in these locations in the project going forward. So this is a quick demo on our RTS function that we've added to FieldGenius for Android version 1.7. Thanks for watching.
Hi, this is Ken with MicroSurvey. I want to show you our new quadrant bearing feature we've added to FieldGenius for Android in our version 1.7 release. Prior to version 1.7, if you were going to do something like an inverse between 2 points, you would get the azimuth in degrees, and that was your only option. So now, if you want to use quadrant bearing, you can go to Settings and Units, and then turn on the quadrant bearing option. Once that's turned on, now when you go ahead and use COGO functionality, you will see your results in quadrant bearing. So north 59 east, south 20 west. You can also input the quadrant bearing into the values. So if we look at traverse, we'll give a starting point again. Let's pick 0.5. And now what I want to do is give it the quadrant. So I'm going to do quadrant 2 and 30 degrees. And again, you can see on the map, we've got the construction line already. If I select done, you'll see it's south 30 east. If I want to choose a different one, let's say quadrant 4 and 20 degrees, it's north 20 west. So as you can see, you get the construction line and you can work easily in quadrant bearing going forward. So just a quick demonstration of the new quadrant bearing feature in FieldGenius for Android version 1.7. Thanks.
Here in this video, I'm going to demonstrate the new point-to-point inversing COGO enhancement. So what this enhancement allows you to do is select 2 points that are stored in the database for you to quickly query the direction and distance between those 2 points. So if I go into the COGO calculator here, the point-to-point inversing function supports all methods within the COGO calculator here, and for this example I'll just use the line intersection option for this demonstration. And if I just tap on point 100 on the map there to define my starting point, and if I just zoom out here just to show the project, and the azimuth that I'm going to want to input is 100. And then just as a separator before entering the second point, we'll just enter 2 periods. And the second point to define the direction here would be 3. And you'll notice that once we input that second point, the map does update and display that direction, and then once I hit done, you'll see that the azimuth input field updates to reflect the direction value there. And if I select on point number 1 for line number 2 starting point, and I'll just zoom out here, and the second direction that I want to input is 1.19, and you'll notice that once I input that second point, it does update again to show the intersection between the two lines, and then once I hit done, it updates and shows the calculated intersection point. And then if we just zoom in, you can just do a quick visual check of that point just to ensure it is what you're expecting. And if it visually looks okay, on the top right here you'll see the plus button with the coordinate value here. So if you hit plus, this just enters you into the new point screen. And right now there's no feature code assigned to this point, and if I just tap in, I can quickly assign a code for this. And you can just do a quick review of that point, and if you do need to add a note record for the point, you can click into that field to add one. But if everything looks fine, just hit save, and that stores the point to the database there, and you're now ready to start your second line intersection calculation if needed. If not, you can just close out and you're just returned back to the map screen here. And that is a quick overview of the new point-to-point inversing COGO enhancement.
The bottom staking toolbar is another way of cycling through your staking list. Notice how I can use the left and right icons, and it just cycles through and automatically highlights the point that I'm about to stake. And that's also a very handy tool for once you've finished staking one point, selecting the next one. So let's do an example here where I'll move closer to my destination point, and I'll pick on the measure button and I'll store a record of that point. And I'm going to save it regardless of the tolerance being exceeded. And now that that point is stored, we can pick on the left or right buttons to cycle through the list until we find another one that we want to stake. And if I turn off this feature to show the staked points, then it doesn't show me point 28, which I just staked before. Thanks for learning about the bottom staking toolbar with me. Let's take a look at picking a point out of the staking list and staking it with GPS equipment. Here we're looking at the staking list on the left-hand side, and this allows me to select different points for staking right off the left-hand side, or if I want to, I can pick the point off the map view screen and it'll highlight on the left-hand panel. This Zoom Extents button here zooms to a level where it shows the difference between your current position and your staking destination. And this little graphical icon here also gives you another graphic to make it easy to find things in a cluttered map view screen. Once we are staking, all we have to do is open up the instrument toolbar, and you'll see the observations toolbar gives you a variety of information to direct you to your point, as I'm tapping on this toolbar, it's updating both metadata about the position and directions to direct you to your point. There are other higher visibility options. If I pick on this icon here, I can see the split screen view, and so that'll give me a better visibility on my point. Now currently it's telling me I need to go 10 meters to the west, and now I'm actually close enough that it highlights in green, showing that I'm within my staking tolerance, and I need to go south about 5 meters. So I'll take that step, and here we go. Now we've actually got both the icons showing in green, although we can tell that I need to fill 1.2 meters. So that's one way of viewing your directions. Or notice how I can pick this icon and now it gives me a direction and a distance to my point. Same information, just expressed differently. For a higher visibility option, pick on this icon for the full screen direction. And that again gives me the same information as before, and it also gives me a choice between polar directions and Cartesian directions. Thanks for your interest in staking a point. I'm going to go into the staking map view so that I can show you how to set up and manage a staking list. So as soon as we enter map view, if there is no staking list connected to this project, we're invited to edit one. So here I'm going to pick on the pencil icon, and that'll allow me to configure my stake list. So here's a list showing me all the points that are part of the project, and we can also see that none of them have been added to the staking list. I can select points individually to add to the staking list, or I can use a filter. So I'll pick on the filter icon here, and I can configure it to filter my points database by, in this case, codes, and I can pick on apply, and now what it's done is it's automatically checked all of the points that have the code road. If I'm happy, I can pick on done, and my stake list will be populated. Now the stake list allows me to select points to stake, and here I can pick on the staking zoom extents so that it will show me, will zoom in on the area that I need to stake, and I can pick on this little icon here if I want to get a graphical preview of where we're going. And there's also this feature for show staked, and so by default it's off, and so what this will do is it'll shorten your staking list as you're working your way through the list. But if you want to be able to see all of the past staked points, this will allow for it. That's all I've got to show you with the staking list.
Hi, this is Ken with MicroSurvey. I'd like to show you a new feature we've added to FieldGenius for Android in our version 1.6 release. We've added the capability to stake a polyline in addition to staking line segments. We've also improved the navigation of going from the map survey screen to the staking map screen. I'm currently in the survey map screen, and I'm just going to select the line I want to stake. It's going to be LL7, and that brings up a pop-up of different actions I can perform on the selected line. If I don't want to perform any actions on this, I can just tap off on the map screen to close the pop-up. But in this case, I do want to perform an action. I want to stake the line, so I'm going to select the stake line segment. This takes me directly to the staking map view and selects the line. The default mode is line segment staking. So as you can see on the map, I've got the line highlighted and the line segment is in solid red. So if I look at the observation toolbar on the top, I can get the station offset of around 30 meters from point PL2 and right 6 meters. I can also look at a different view if I want to see larger numbers here that make it easier to read in the field. But in this case, I don't want to stake the line segment, I want to stake a polyline. So on the map panel, I'm going to select the down chevron and select the polyline option. When I do that, since it's a new mode, it clears the selected line, and I'm just going to have to select it again. I selected LL7 from the data panel, and it's now selected. And you can see from the stationing now I'm 51 meters down the line from the start point, which is PL1. So if I navigate to the line, and I'm using just a simulator on my computer to do this, you can see that I'm now at the station and I'm in tolerance with the green check mark, and I can take a measurement. If I want to go further down the line, again, I can just walk down the line and see my station as I go down the line. And again, to stake on the curve, I just need to walk to the curve, get it within tolerance, and find the point I want on the curve. You can see your stationing and your distance right or left on the observation toolbar, but you can also see the visual display in real time on the map as you're walking around. Thanks.
Hi, this is Ken with MicroSurvey. I want to show you a new enhancement we've made to staking in FieldGenius for Android version 1.7. So to get to the staking menu from Survey, you can select a line or a point. In this case, I'm just going to select a point, and let's say I want to stake to that point. This will take me to the staking screen and allow me to navigate and stake to that point. But what if I want to stake a line between two existing points? We can do that now. So instead of staking a point, I'm going to go to staking a line to bring up the line staking menu. And now the new option we have, instead of polyline or line segment, is defined by points. So I'm not going to define a line. I can do a straight line between 2 points. So I'm just tapping on the map here to select my 2 points, the initial point and the end point. And now we have the line we want to stake to. And we can navigate to that line. If I want to do an arc, just as easy, I select the arc option and just add the midpoint of the arc between those 2 points. And now I've got the arc and the navigation. And I can see the navigation in the observation toolbar, or if I want, I can open up a larger navigation screen and close my data panel, and then navigate to the arc and stake on that arc. So, quick video on how to stake to points on straight lines and arcs in FieldGenius for Android. Thanks!
I'm going to configure a profile that will allow me to save all the settings I need to connect to a GNSS reference station. Let's start by going to Select Instrument in the Instrument Profiles list and add a profile. I'll select Reference, my make, in this case is StoneX, my model, in this case is S900T. I can customize the name I want to give, or I can leave it with the default. I'll create it. First step is setting up communication. That allows me to do a Bluetooth connection to my receiver. I'll pick on search. Now while it searches, I'm checking on the serial numbers that are on both the base and the rover that I have powered on right now to be sure that I'll connect to the base serial number. So my base serial number ends with the digits 225, so I'll connect to it. There's the audio confirmation that I'm connected. Now that I am connected, I can review some information. If I pick on the Information button, this allows me to see what my current position at the base is. I can look at the position in project coordinates in the map projection that I have selected, or geographic coordinates. Notice how I haven't set up the antenna height yet, so my antenna height is 0. Also, if I need to check on technical information about the instrument, I can select Receiver Info, and I can review information such as battery level and firmware version. I'm going to stop in this video, so I'll pick on Done, and it warns me that I'm not finished my setup. That's okay. I'll tell it to cancel, and we can continue the connection later on. I'm connected to a GNSS reference station, and I'd like to set up its tolerance. Pick on Setup Tolerance, and here I can specify the minimum status for GPS position that we would like the base to filter for. So we're going to tell it to only transmit an RTK connection if it has 5 or more satellites, if the PDOP is 4 or less, and the elevation mask, that is the elevation of satellites above the horizon, is no more than 10 degrees in this case. So I'll select OK, and now we've configured our tolerance. We're going to go through setting up our reference position using the Measure option. I'll select Set Up Reference Position, switching over to Observe, and here you can see that we've got information about our current position. It's an autonomous position, and I can pick on the Start button to start measuring and averaging a position. I'm going to let it go to about 20 seconds and then I'll stop it, and we'll set that as our starting point. There we go, pick stop. And you notice how we've got the option of restarting, but if I'm satisfied with the position that I've measured, I select Done. Now let's store this point. I'll assign a point number and a description. And I'm going to set it as a control point, and I'll pick on Save. There. Now we've set the position from which the receiver will be transmitting its corrections. We're going to configure the antenna height for a GNSS reference receiver. So you can select the model of the antenna. In this case, there's only one to work with, but you'll notice that if you have a non-standard model, you've always got the option of performing user-defined. I'll go with the S900T. And you'll also notice under Measure Point, you've got the option of selecting 2 different choices. If I measure to the bottom of the antenna mount, then it'll apply the appropriate offsets. Or if I wish to use a slant measurement, then you notice how the offsets are changed. These are things that you can also configure in a user-defined profile if you wish. You can manually input those values. What I'll do is I'll select bottom of antenna mount, and then I'm going to perform my measurement. Enter the value in centimeters or in your project units. Select OK. And now, if I go back in and I check my current information about my position, you'll notice how the antenna height is updated, and it's recording an accurate but uncorrected elevation. We're now going to set up corrections so we can configure the GNSS receiver so that it will transmit an RTK signal over, in this case, a UHF radio signal. First step is to set up communication, where I can identify I'm using the UHF radio module. Here I can specify whether it's an internal or an external radio. In this case, internal is my only choice. I can go into radio settings to configure specifics about how the radio is going to be configured. So here we can set the protocol, the channel spacing, transmission power, and the channel. The options that you see will vary from radio model to radio model, and of course it's important to ensure that the settings you set here in the reference receiver are going to match in the rover receiver later on. I'll pick apply to make those settings so. Now I can pick done. Final step, I'm going to choose a format, and the base station ID is an optional feature. If you're on a job site where you have multiple reference receivers and you want to make sure that you only listen to one, then you assign a base station ID to your station. In this case, I'm just going to set it as 0 and pick done. Final step, start transmitting. There we go. And when I pick on done, Bluetooth will disconnect and we'll be able to connect to a rover. I'm now going to go through the process that you would need to follow if you have powered down your GPS base, or if you're coming back the next day, you need to reestablish the receiver location, and in this case I'm going to show you how you can move the receiver to a different measured position. So when we were here on the first day, we had set up the receiver on point 1001 that you see here, and near the end of the day we measured to a nail at point 2 over here. And so what we're going to do now is move the receiver to point 2, enter the corrected antenna height, and start transmitting an RTK signal from point 2. So let's go through that process. I'm going to go to Select Instrument, and we'll pick on the receiver profile and connect to it. Now I've already measured my antenna height, and it's going to be 1.75 meters. Now we're connected. I'm going to correct the antenna height. Now I'm going to go to set up reference position, and in this case I'm going to use the known option, and I'm going to select from point list. So I'll pick on that button, and what this will do is this will give me a list of all of the points that have been measured with GPS. That's a requirement for you to use this method. And so I can select point 2. Final step is set up corrections and start transmitting. Now I can see from the display on the instrument that it is transmitting a correction signal. So I'll select done, and that disconnects from the base, and that allows me to now connect to my rover. click on Done now and return to Map View. So now we can see what my current position is, and it's always an excellent check to try to stake to an existing point to confirm that you have configured everything correctly. So I'm going to switch from Map View to Staking View, and I'll add point 1001 to my staking list. That looks ready to go, and I'll pick, I'm already getting directions to that point, so let's head over there. Coming to the mark. Now as I level things up and I get a good position, I'm already starting to see some green as our staking tolerance requirements are met. And I am seeing an error in elevation, which is probably my fault and something that I should resolve by checking antenna height measurements. There we go. Thanks for following along. Here we're going to set up a reference position. If we've set up the GNSS receiver on a location and we have a mapping plane coordinate and an ellipsoid elevation to program that receiver to. So we're going to set up reference position. I've selected the known option, but I'm going to switch over to Cartesian. In here I can input the northing in this case. And now my easting. And the ellipsoid elevation. When I select Done, I have the option of storing the point. And that'll allow us to refer to this point in the future. Here we're going to perform a setup of the reference if we've set up the reference position at a known location and we have a geodetic latitude longitude value to enter. So I've selected the known option, and here I'm going to manually input that latitude longitude in degrees, minutes, and seconds format. Here's my latitude, and I'll input my longitude. And an ellipsoidal height. Now we're ready. We can select Done. I'll store that point. Give it a description, and I can save it. And now our GPS receiver knows what to do when we finally set up corrections. So I've completed configuring a GNSS reference station to start transmitting an RTK signal over a radio. Now I'm going to switch over to the rover and get an RTK signal. So I'll select Done, and I'm disconnecting from the base. Now I'm going to add a new profile for my rover. Select the rover option. StoneX is my make. S900A is my model. I can customize the name if I like, but I'll just use the default and pick Create. First step is to set up communication and search for the Bluetooth signal of the rover. As it's searching, I'm checking on the serial numbers to make sure that I connect to the rover Bluetooth. The serial number for my rover ends in 228, so I know that I'm connecting to the right device. Let's pick Connect.
Bluetooth connected.
Now that I'm connected to the device, I can see that I have an uncorrected position, and if I select on the Information button, I can review what type of connection I have. Right now it's connected with float because it's remembering a previous connection, but we are going to need to configure this properly, which we'll do in the next video. Let's go over the process of creating a network rover profile that uses data collector internet as a method for establishing an RTK link. Data collector internet allows you to establish an internet connection using either Wi-Fi or wireless on your mobile device. Let's first create a profile. I'll pick Select Instrument. I'll pick Add Profile. I'll select my make. I'll select my model. I'll tell it to assume that this is a rover, and I'll give it a friendly name. Note that the friendly name can't have any spaces in it. When I create it, I can see the next steps in the setup process. Pick Setup Communication to search for and connect to your receiver over Bluetooth. When I open the option, I can select Search. While it's searching, if it cancels, notice how down in the bottom there's a Refresh List button. You can pick that if you need to re-trigger the search. While I'm waiting, I'm checking that my receiver is powered on and that it's discoverable, and I can check its serial number, which I'll see in the list here if it's found. I can identify that is the serial number of my receiver. I select it and I pick Connect. We're now connected to the instrument. And before I set up the other parameters, I can pick on the I button if I want to take a look at my position information. So here I can see the geographic coordinates that are being sent from the receiver. I can confirm that it's an autonomous position right now. While I'm connected to this instrument, I can also open up extended options and ask for receiver info if I need to access information such as firmware version or battery state. Now that I'm connected, I can configure other parameters for my instrument profile. Setup corrections allows me to set up the parameters needed for my RTK link as a network rover. I can highlight Internet as my connection method, and I'll start by select and set up device. So this allows me to specify the method by which Internet access is obtained. Because we're doing data connector Internet, all I have to do is pick Done from this option. Next, we'll set up the data source. Before we go into this option, we need to make sure that we have all the information that's been sent to us by the NTRIP service provider. We'll need an IP address. We'll need to select a connection method. We'll have been given a username and a password and a port number as well. A few notes: the address must be an IP address. It cannot be a URL. And the username and password are unique to you, and they're only used when you select a mount point. I'm going to enter the configuration for my server, but the parameters are going to be hidden from you. When I pick Done, these parameters will be saved. Next, we're going to set up format. In most cases, options are auto-connected as soon as you select a mount point and connect to it. But these options are here in case you're using mount points with special requirements. I'm just going to leave this at auto-detect and any. Now that we've configured our RTK link, we can connect to it. So we've now sent the command to the rover to connect to the Internet and to find the source table. Here's the source table. I can select an appropriate mount point from the list, and it'll start the connection. Here's an option where you can confirm any special needs for this mount point, but in most cases you just hit confirm and it will auto-detect. Now we've established a link to the mount point, but it's a good idea to go back in and finish performing the setup. We'll set the antenna height. And this allows us to select the antenna model if there's more than one. We can refer to the measurement reference point, and we can enter the measured component of the instrument height. The active tolerance can be referenced by picking on the pull down to see what the properties of the current tolerance are, or you can edit the tolerance by picking the Further Options dialog. Now that I've configured the instrument profile, I can access it several ways. I can pick on Select Instrument to see all the instrument profiles, or if I'm in the survey or the staking map views, I can either pick the Reconnect button in the bottom right, or go to Select Instrument, and again access the list of instrument profiles. Let me do a connection, and when it connects, it will use the same settings that you had before. After we're connected, I'll just show you how to verify your position and possibly change a mount point.
Float.
Now we're connected. I can look at position information to see what my solution type is. If I wanted to change my mount point, then I'd access Corrections and select Connect, and this will display the source table, and I can select a different mount point.
Real-time differential.
Or I picked a different mount point and connect. And on the map view, we'll see the measure button in the bottom right corner. We'll always display our solution, and we're looking for RTK for the RTK fix solution. You can also use the observations toolbar to see if your current solution matches your tolerance mode settings. Let's go over the process of creating an instrument profile for a network rover that uses the GSM module in your receiver to establish an RTK connection. We'll start by creating an instrument profile. I can pick on Select Instrument. I can pick Add Profile to give it a name. First I'll select my make, then my model. I'll specify that I want this to be treated as a rover, and then I'll type in a friendly name for it. In this case, be aware that you can't have any spaces in your name. When I pick Create, my profile is created. Pick Setup Communication to search for and connect to your receiver over Bluetooth. When I open the option, I can select Search. While it's searching, if it cancels, notice how down in the bottom there's a Refresh List button. You can pick that if you need to re-trigger the search. While I'm waiting, I'm checking that my receiver is powered on and that it's discoverable, and I can check its serial number, which I'll see in the list here if it's found. I can identify that is the serial number of my receiver. I select it and I pick Connect. We're now connected to the instrument, and before I set up the other parameters, I can pick on the I button if I want to take a look at my position information. So here I can see the geographic coordinates that are being sent from the receiver. I can confirm that it's an autonomous position right now. If I pick on project coordinates, it'll show me Cartesian coordinates. While I'm connected to this instrument, I can also open up extended options and ask for receiver info if I need to access information such as firmware version or battery state. Now that my Bluetooth connection is established, I can configure other aspects of my instrument profile. Let's pick on Setup Corrections. This will allow me to input the parameters that affect my RTK connection. In this case, I have a SIM card in my receiver, so I'm going to attain internet access through a cellular network from the receiver. I'll go to Select and Set Up Device, and here I'm going to pick GNSS Mobile. I only have one modem in this device, so default will work. APN username and password are values that are provided by your mobile provider. So in this case, I'm using a SIM card from Rogers Communication, and their APN is internet.com. Their username is WAPuser. And their password is the same for all customers, is just WAP. So these are settings that work for my SIM card. Unless you're a Rogers customer, you'll probably need to check a website to find out what the APN username and password are for your provider. Username and password sometimes aren't required. When I pick Done, these values are saved. Next, we'll set up the data source. Before we go into this option, we need to make sure that we have all the information that's been sent to us by the NTRIP service provider. We'll need an IP address, we'll need to select a connection method, we'll have been given a username and a password, and a port number as well. A few notes. The address must be an IP address. It cannot be a URL. And the username and password are unique to you, and they're only used when you select a mount point. I'm going to enter the configuration for my server, but the parameters are going to be hidden from you. When I pick Done, these parameters will be saved. Next, we're going to set up format. In most cases, options are auto-connected as soon as you select a mount point and connect to it. But these options are here in case you're using mount points with special requirements. I'm just going to leave this at auto detect and any. Now that we've configured our RTK link, we can connect to it. So we've now sent the command to the rover to connect to the internet and to find the source table. Here's the source table. I can select an appropriate mount point from the list, and it'll start the connection. Here's an option where you can confirm any special needs for this mount point, but in most cases you just hit confirm and it will auto-detect. Now we've established a link to the mount point, but it's a good idea to go back in and finish performing the setup. We'll set the antenna height. And this allows us to select the antenna model if there's more than one. We can refer to the measurement reference point, and we can enter the measured component of the instrument height. The active tolerance can be referenced by picking on the pull down to see what the properties of the current tolerance are, or you can edit the tolerance by picking the Further Options dialog. Now that I've configured the instrument profile, I can access it several ways. I can pick on Select Instrument to see all the instrument profiles, or if I'm in the survey or the staking map views, I can either pick the Reconnect button in the bottom right, or go to Select Instrument, and again access the list of instrument profiles. Let me do a connection. And when it connects, it will use the same settings that you had before. After we're connected, I'll just show you how to verify your position and possibly change a mount point.
Float.
Now we're connected. I can look at position information to see what my solution type is. If I wanted to change my mount point, then I'd access Corrections and select Connect, and this will display the source table, and I can select a different mount point. Or I picked a different mount point and connect. And on the map view, we'll see the measure button in the bottom right corner will always display our solution, and we're looking for RTK for the RTK fix solution. You can also use the observations toolbar to see if your current solution matches your tolerance mode settings. Here we're going to configure the antenna height for our GPS rover. You can select the model of the antenna. Notice how you've got a user-defined option. You can also select what reference point you're using when you perform your measurement. In this case, I'll select the height mark for a slant measurement, and here I'll perform the measurement to the reference mark on the device. I've stored the measurement in the units of my project, in this case meters. Select OK. Now it's configured to output accurate elevations. We're now going to perform a correction setup for this GPS rover so that it can receive an RTK signal over, in this case, a radio that's being transmitted from a base. I'll select Setup Communication. We can select what type of a connection we have, in this case a radio. We can identify whether the radio is an internal device or an external device that would be connected to via a serial port. We can go into the radio settings to configure specifics about the radio so that they'll match the signal that's being sent from the base. Here I can identify the protocol, channel spacing, and the channel, and these match what I've configured on the reference receiver. Select Apply. Now I can tell from the audio feedback and also from the icons on the receiver that the radio is now receiving signals. When I select Done, the last step is setting up the format so that it matches the format being transmitted by the base. In this case, we'll select RTCM2. The base station ID is a feature that allows you to filter so that you will receive corrections only from a specific base transmitting a specific base station ID. In most cases, you've only got one base station on the job site, so any is just fine. Select Done here and select Start Receiving. I've just completed connecting my rover to a reference base over a radio RTK link, and I'd like to do a check to make sure that I've got my antenna height set up, and I'll do that just by doing a stake to the base. So I'll pick on Done here from the setup dialog. I'm going to go to the staking section. I will add the base point that I've just stored to my list. Now I can see I'm being directed to it, and I have the base set up on a flat surface. So all that I really need to do to perform this test is get close to the base, level up, and just check to see what my cut or fill value is. So I'm looking at roughly 5 centimeters, and that's about what I'm expecting. So that's a successful test. Here I'm going to go through an example of using GNSS local transformations. In this case, what I've done is, if you look down at the Pacific Ocean, I've imported 3 points, and you can see from the icon higher up that my GPS location is up in British Columbia. I'm going to perform an operation that will synchronize the coordinate system defined by the imported points that you see down at the Pacific Ocean, and it will link them up to our GPS positions so that we can start generating coordinates in the local datum that's defined by the ASCII points. So we're going to go to Project Data, Local Transformation, and here we've got lots of options for setting up transformation. In this case, I'm going to use Calculate from Point Pairs. Now, I have 4 different types of point pairs. 2 of them are pre-measured. One of them is pre-measured and has a mistake in it, and one of them I'm going to measure or observe during this process. Let's go through the first 2 examples. So I'll go to Add Pair, and in this case, I've got it pre-measured, but I don't have the coordinates stored. So I will pick on New for local control. And in this case, it is going to be 1004. I'm going to give it the code of IP. And I'll manually enter the coordinate, 1000, 1100. Okay, so I'll save that one. And now what I'm going to do is match it to a GPS measurement. So I pick Select Existing, and in this case I'm matching it to 0.4. So I'll add that first pair. So a shift has already been computed, and currently you're seeing the delta north, delta east, delta H as the residuals, and they're all 0 because there are no potential conflicting control points. So let's add another pair of points to start to see more options. So this time I'm going to go to Select Existing, and I'll select my 1003, and then select Existing GNSS Control, and I'll select 3. I'll add that pair. Now we have a pair of points, and at this stage we're now able to compute a scale factor and a rotation if necessary. And what you'll see is that you've got 2 different options for scale factor. You can either calculate for a best fit, and this is something that you do if you're mixing ground points and grid reference points, or if you know that we shouldn't be applying a scale factor, we can set it to fix to 1.0. So notice what happens with your residuals when you have it set with no scale factor. Then you're seeing small residuals because it's compensating for the difference in distance between your measured points and your input points. Or, if I change it again to calculate, then the scale factor is compensating for the difference in the distance, and so you've got all zeros in your delta north, delta east residuals. The delta H is caused by the fact that there's a difference between the 2 measured points and the elevations of the input points. And what we're going to discover is all of these points are set to exactly the same elevation, so we will see larger than you would normally see delta H residuals. Right now what it's doing is it's noticing that there's a 7 centimeter difference between the 2 points, and it's just splitting the difference with that delta H. Now, if I would like to have FieldGenius compensate for those differences, if this was an example where you might want to compensate for the fact that you've been given control points in a geoid, but you don't have that geoid to measure from, you can force FieldGenius to change the way the vertical reference is being interpreted by using the inclined plane option. Now, you don't see an update yet because you have to have 3 points before it can do any computation. But I'll just mention that feature, but I'm not going to do anything else with it. I'm going to go back to constant shift, and I'm going to deselect using 1004 or 1003 for control. So now we will see delta H residuals, but I like it that way because we're just going to be using 1004 as our benchmark. Okay, now let's add another pair. In this case, this is going to be the point that is in error. So 1002 is the GPS measurement, and 2 is the imported point. I will add that pair. So now what we can see is the residuals in north and east are much larger, and that's indicating that we've got a problem with one of our control points. I'll deselect vertical right away so that our residual in H just goes back to 0 at 1004, but that doesn't resolve the fact that whether I have a scale factor on or a scale factor off, I'm still seeing large residuals in the range of meters. So that's an indication that you need to go back and look at your control points and see if you can find the cause. So it's easy enough to deselect control points and have the program recalculate based on that input. And so you'll find that when I deselect horizontal control for any of the other ones, it just re-updates itself. But we still see large residuals at the 3 different points. And in this case, I will deselect using 1002 as control. We notice that 1004 and 1003 go back to having small residuals, and we can actually see if 2 is in fact the one that's in error, which I can tell you it is, we can see that it's off by roughly 10 meters in both directions. Now I'm going to add a 4th point, and that'll give us a final confirmation that it was actually 2 that was the problem. So in this case, I have one more control point available. Let's go back to the points so that you can see. We have a point called 1001, and I haven't pre-measured this one with my GPS, but I will. And while I'm in here, notice how, now that we've already set up our control pairs, how points 1004 and 4 are linked in the coordinate list. And they will stay there as long as these pairs of points are in the local transformation dialog. Okay, let's go and measure point 1. I'm going to go back into local transformation. You'll notice that it's remembered all my definitions, but it hasn't applied them yet. I'm going to add one more pair. The control point is 1001. And in this case, I don't have a pre-existing measurement. I'm going to go to measure. There we go. Measurement is taken. I'll store the position, just following along with my previous convention. I'm going to call it point 1 to match 1001, and I'll give it the description GNSS. The point is now saved, and it's paired with point 1001. When I pick on Add Pair, we return again to the localization parameters list. And so here I can see that we're looking at residuals that are in the centimeter range. They're not quite as good as I would normally accept for work, but in this case, some of the measurements were taken under not perfect conditions. But what we can see is we've got sub 5 centimeter residuals for points 4, 3, and 1, and you'll notice how there's still large residual for point 1002. And so that's, now that we've got 4 points, that's a way of just confirming that we've got good control on at least one of the or on at least 3 of the points. And one other thing that's good practice again is turn off using vertical for all of the points except for one that I want to set as my benchmark, and that's only because it makes it simpler to ensure that your vertical datum is perfectly vertical. Now that this is done, the final step is we pick on Apply, and we get this message here that all of the measured points that we've got in our project are now going to be shifted and transformed, and all of our future measurements will also be transformed by the parameters that we see in this list. Here's our local transformation parameters. And now I'm going to go back to the map view into survey mode. We can now see that our control points and our plan points are aligned. Our map view is actually displaying true north as up, as opposed to the north that was defined in the ASCII points. And if we look at the observations toolbar, we're going to see that the northings, eastings, and elevations that we store as we work are going to be in the same datum as the ASCII points that were originally stored. Thanks so much for following along. In this short movie, we'll talk about initializing the IMU to be used with FieldGenius for Android. You can see that I've connected to a device that supports and is licensed for tilt correction. You'll see that I now have an RTK fixed solution, which is important for this feature to work. You'll see that I've also entered an accurate antenna height. That's also very important for a tilt correction to be computed. Now down the bottom, I'm going to pick on the Enable button. And now tilt correction is enabled. And when I return to the map view, what we'll see in the top right corner is that there's an icon indicating that tilt correction is enabled, but it's not set up yet. And if you look at your measure button, you'll see that it's cycling between showing the RTK fixed and initialize IMU. So that's my signal that it's time for me to follow the procedure recommended by the manufacturer for initializing the IMU. Now this varies by device. With the GS18, I know you just need to walk in a small circle. With this StoneX device, what I'm doing is I'm leaving the bottom of the rod in one place and I'm moving the receiver head in a circular motion. And now we can see we've got a green check mark, so that means that IMU is initialized and tilt correction is now enabled. In this short movie, we're going to look at using the basic tilt correction mode. What you can see here is I've stored a point 1 in my project before I turned on tilt correction, and you can see from the icon in the top right corner that tilt correction is now enabled. And if I pick on that icon, then we can see a live feedback of what the tilt of the instrument is. So I have placed my rod at the same location as point number 1, except now I'm going to tilt it noticeably, and I'm going to measure the point. Now we'll have stored a point 2. We'll open up the data panel. Here we can see we've got both a point 1 and a point 2 right on top of each other. And what I suppose I could do here is I'll pick in here and I'll try to stake to point 1. And I'll do it with a completely different tilt in a different direction. And there it's giving me directions 2.1, and you'll even notice if I open up the tilt correction dialog, let's pick something else, that even as I move the instrument around, you'll see that it's still giving me consistent directions back to point 1. So we can see that we're within about 3 or 2 centimeters of our destination. There we go. That was basic tilt correction mode. Thanks for following. I'd like to show you the tilt rejection mode that works with all GPS receivers that support IMU tilt correction. I'll go into my instrument settings and I'll go down to the tilt correction section and I pick on the 3-button settings button and access the settings. So here I've turned on tilt rejection, and so what this function will do, unlike when you don't have tilt rejection, is it will warn you when your tilt is beyond the value that you've set, which you can see here is 25 degrees, and it will prevent you from storing a point until you're closer to that value, or until you're inside that value rather. So I'll pick on OK here, and I'll pick on Done here, and let me just show you what happens if I'm staking the same point that's labeled as 1 and 2, and we'll take a look at our tilt indicator here. You'll see that it's green when I'm inside of that 25 degree tolerance, but now when I move it outside, you'll see that it's red. And at this point, if I try to measure a point, I'll hit my measurement button. I can see that it is not going to measure because I've got the message tilt rejected. And in fact, what you'll see is if I straighten things up until it's inside the tolerance, then it's going to start storing it. There we go, and it stored the point. Alternatively, if I have things tilted outside of the tolerance, if I measure another point when I'm outside of the tolerance, what we'll see is we have an override tolerance option. So I can pick on that if for some reason I just have to measure it outside of my tolerance, and I have to confirm by hitting store position on the other button. And there it will store the point, and what you'll find when you look at your results is that it has tilt corrected that measurement even though it's outside of tolerance. And that's what happens whenever you have tilt correction mode enabled. Thanks for learning about tilt correction, tilt rejection feature.
Here in this video, I'm going to give a quick overview of how to store GIS feature points and lines. So I've just started a new project here, and if I expand the data panel out, and I'm already in my codes panel here. So what you're looking at on the side here are all of the GIS points and line codes that are stored in the feature file here that I want to use to collect some points here. So the first example I'll show is collecting a culvert GIS feature. So if I just select on that using the lines data panel, it automatically sets the culvert code as active. And if I just prompt an observation here, it'll store the point's position. And here it'll just bring me into the attribute screen here. So I've set the culvert code. If it was an incorrect feature code that you selected, just use the arrow picker on the side there to go back into your code list and change out the code there for the correct one. But since this is the correct code for myself, then all I want to do now is just add the additional attributes that are tied to this feature. So for the culvert, it's a PVC type. And for the remark section here, we'll just input the size of the culvert here. And the layer that's associated for this feature. And then once everything looks good for the points attributes, you can just hit save, and that saves the feature with the attributes there. If at any time you do need to edit the attribute, just select on the point from the map screen and just hit edit point. And this will just bring you back into the points attributes page here for you to edit the feature code or the attributes if needed. But I'll just save this with no changes. And if I flip back to my codes panel, and if I just demonstrate how to collect a feature line, GIS feature line here, I'll just select on the fence wall code here, and you'll see down on the top of the toolbar it automatically sets the fence wall code and also the fence wall 1 figure. And if I just move over here, and then if I prompt the observation for the fence wall, for the line here, it's going to ask for the attributes for this line, just like the points. If you did need to change the code, just use the picker and go into your codes list and just exchange the code out there if needed. But the code is correct here, and I'll just fill in the attributes. So this is a chain link fence for the type, and then the size of the chain link fence for the remark is just 3 feet. by 8, and then the length of this fence. And then the layer. And once you enter in the attributes and just quickly review them, just to make sure they are what you intend to store, and then just hit save. So this stores the first point for the line, and then now what you have to do is move and collect the other end of the line there. So if we start and prompt the next point here, and then it automatically brings us back into the new point page here for the line attributes, and it'll, when you store the second point for the vertex for the line there, it'll just reuse the attributes that were entered in when you stored the first point. So just hit save, and you'll see it does store that line there. And then if you did have another vertex with the same line attributes, you can move and collect the next line entity that also has the same line attributes there. So if I just store this point, you'll see it just brings us back to the new point page, and it is just reusing the same attributes that were stored from the first point there for the line. And then just hit save. And then if at any time you did need to edit the attributes on this line, just select on the line, and then there's an Edit GIS Attributes option on the Quick Action menu for you to come in and change the line attributes here if needed. But I'll just save this with no changes. And that is a quick overview of how to store GIS feature points and lines. In this video, I'm going to demonstrate the feature manager. So from the new project page and down below, you'll see the feature list field, and beside that you'll see the feature manager option for you to click into. So if we click into that, that brings you into the feature files page, and from within here you can edit an existing feature file to add or edit features, or you can configure a new file to be used. If I click on new file, from within this page you'll see an option to extract from DBF. So if you already have a feature list that was exported from another software, you can hit the extract from DBF option and browse to the shapefile to extract the feature set. So if I hit on that option, and if I just browse to the internal storage of this device and into my documents folder and into my shapefile folder here, there's a culvert DBF for me to extract from. So if I select on this, it automatically pulls in the feature name, which is culvert, and it does pull in the attributes associated with this feature. So if you do need to edit the existing attributes, you can click on the three-dot menu next to those attributes, or if you need to add additional attributes for this feature, just select on the add attribute, and you can start adding in additional attributes. But if everything looks fine, just hit save, and this just adds the feature into the list here. If you didn't have a shapefile or a feature set that was extracted from another software, you can just hit the add option and start manually adding the features you want to the file. So for example, if I wanted to add an iron post feature, and I'll add an attribute as a Boolean type, and I'll describe this as countersunk. Save that, and I'll just add one additional numeric attribute input for the depth if that post was countersunk. And once you've configured the new feature here and everything looks fine, you can hit save. This will return you back to the feature editor page, and you'll see the save option on the top right for you to hit save, which will then prompt you to input a new file name to save as for the feature file there. And then once you hit save, it'll return you back to the feature files page, and from here you can select and tap on the new file there, and that will bring you back to the new project page. And you'll see that the feature file that was selected is now going to be used to create the new project. Thanks for taking interest in this video. Here in this video, I'm going to give a quick demonstration on how to use the new report feedback tool. So you'll find this in the settings. So if you click into there, they get into the settings page, and down below you'll see a new report feedback section for you to click into, which will link you to the page. And what this report feedback tool allows you to do is send an email to our support reporting an error that you're having, or requesting a new feature for additional functionality that is missing in the program that you would like to see added. But before you can do that, you'll have to fill in the required information. So if I just click into this box, since I've already pre-filled this out, you'll see my name and my email. So at minimum, you will need to provide your name and the email, and the company name and telephone number are optional fields to provide. But once that required information is filled out, you can click into either the report error or the request feature section, depending on the inquiry. So for this example, I'll just report an error, and I'll click into there, and then you can just provide a quick subject just to give a quick explanation or a title for the issue. So for example, I'm experiencing some crashing. And in the message, just provide a quick explanation of the issue that you're running into. So you can give just a quick message, and then if you do have attachments, there's the attach option there for you to browse to the file and attach it. So for example, the shapefile, I'm having issues importing, and then if you did want to provide the instrument profile that you were connected to, just to provide some extra details, you can select on the list here and select the profile. But in this case, since I wasn't connected to an instrument, I'll just leave that as is, and I'll just have to consent to process the information. And once you hit that consent button and you hit send, that will send an email to the support help desk, and you'll receive a notification just notifying you that the message has been received. And that is how you would use the new report feedback tool.